Hello guys, welcome to i-tutor Academy. In today's session, we will start with Unit 14 MMPC005 correlation. So let's see the objectives of this unit. After completion of this unit, you should be able to understand the meaning of correlation, compute the correlation coefficient between two variables from sample observation, test for the significance of the correlation coefficient, identify the confidence limit for the population correlation coefficient from the observed sample correlation coefficient, and compute the rank correlation coefficient when ranking rather than actual value for variable are known, appreciate some practical applications of correlation, become aware of the concept of autocorrelation and its application in time series analysis. And structure of these units are: there is an introduction part, the correlation coefficient, testing for the significance of the correlation coefficient, rank correlation and practical application of correlation, autocorrelation and time series analysis, summary, self-assessment exercise, and keywords are there. So let's begin with the introduction part. We often encounter situation where data appears as pair of figures relating to two variables, and a correlation problem consider the joint variation of two measurements and uh, two measurement, neither of which is restricted by the experimenter. The regression problem, which is treated in, that is on unit 5, consider the frequency distribution of one variable, that is called the dependent variable, when another independent variable is held fixed at each of several levels. And example of correlation problems are found in the study of relationship between IQ and aggregate percentage marks obtained by a person in SSC examination, blood pressure and metabolism, or the relation between height and weight of individuals. In this example, both variables are observed as they naturally occur, since neither variable is fixed at predetermined levels. An example of regression problem can be found in the study of the yield of crops grown with a different amount of fertilizers and the length of life of certain animal exposed to different amount of radiation, the hardness of plastics which are heat treated for different period of time, and so on. And here is a scatter diagram give us two very useful type of information. First, we can observe patterns between variables that indicate whether the variable are related. Secondly, if the variable are related, we can get an idea of what kind of relationship would describe the relation correlation. Examine the first. Year-wise data on advertisement, expenditure and sales is here. So here is the one table, and figure 1 is scatter diagram. So this is a scatter diagram, and the scatter diagram may exhibit different kind of patterns. Some typical patterns indicating different correlation between two variables are shown in figure 2, and what we shall study next is precise and quantitative measure of the degree of association between two variables and the correlation coefficient. The correlation coefficient, definition and interpretation. The correlation coefficient measures the degree of association between two variables, that is x and y. Pearson's formula for correlation coefficient is given as R, that is R is the correlation coefficient between x and y. Sigma x and sigma y are the standard deviation of x and y respectively, and n is the number of values of the pair of variable x and y in the given data. The expression and it is also known as the covariance between x and y. Here R is also called the Pearson's product moment correlation coefficient. And here is the second figure, that is different type of association between variables. The following form for carrying out computation of the correlation coefficient is perhaps more convenient. And here is activity A, activity B is here, and a sample calculation also here. So you just go through your MMPC005 material and it will help you for your more understanding. And a shortcut procedure for calculation of correlation also here based on the equation, and activity C also here. So you just refer the MMPC005 unit 14 subsection 2. Okay, and next one is testing for the significance of the correlation coefficient. Once the correlation coefficient has been calculated from sample data, one is normally interested in asking the question, is there an association between the variables, or with what confidence can we make a statement about the association between the variable. Such a question are best answered statistically by using one of the following two commonly used procedures: providing confidence limit for the population correlation coefficient from the sample size n and the sample correlation coefficient r. If this confidence interval includes the value 0, then we say that r is not significant, implying thereby that the population correlation coefficient may be 0 and the value of r may be due to sampling variability. Testing the null hypothesis that population correlation coefficient equals 0 versus the alternative hypothesis that it does not by using the t statistics. The use of both these procedures is now illustrated. The value of the sample correlation coefficient is used as an estimate of the true population correlation P. It is desirable to include a confidence interval for the true value along with the sample statistics. There are several methods for obtaining the confidence interval for P. However, the most straightforward method is to use the chart such as shown in the figure 3, that is confidence band for population correlation. And once R has been calculated, the chart can be used to determine the upper and lower value of the interval for the sample size used. And here is also the equations, and if a confidence interval for P includes the value 0, then R is not considered significant, since that value of R may be due to nothing more than sampling variability. This method of using charts to determine the confidence interval is convenient, though of course we must use a different chart for different confidence limits. And the tabled value for a t distribution with 98 degree of freedom and a 5% level of significance is equal to 1.99. Since the calculated t exceeds this figure of 1.99, we can conclude that this correlation coefficient of 0.2 on samples of size 100 could be considered significantly different from 0, or alternatively that there is statistically significant association between the variables. So this is about today's section, and the next subsections of unit 14 we will discuss on next video. In between, any doubts you can contact us also. For more Ignou MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.